Hey folks, my name is Hunor, and in this mini course I'm going to explain how to create a game heavily inspired by Stick Hero with JavaScript and Canvas. Stick Hero is originally a mobile game published by Ketchup, which I have no association with, but I thought it's an easy and fun game to recreate with Canvas. This is a mini course because I'm not going to explain everything. We are not going through the code line by line, and we won't code along. I'm going to give you a quick overview of how the game is built up and explain some of the tricky parts, and then you can look up the rest in the source code. You can find a wall game on codepen, so if you want to try it out and see what we are getting into, check out the link below in the description. You can play the game there, and there you can see the wall source code. In this project, I'm using a bit of HTML and CSS, but primarily JavaScript and Canvas. We are going through how the game works in general, and I'm going to give you a quick introduction to Canvas and how am I using it in this game. So let's get into it. The game has a loop of 5 different phases. Initially, the game is waiting for user input and nothing is happening. Then once the player holds the mouse down, the game is stretching a stick upwards till the mouse is released. Then once the mouse is released, the stick starts turning and it falls down, hopefully, on the next platform. If that's the case, the hero walks through the stick. And finally, once the hero reaches the next platform, the wall scene is transitioning to the left to center the hero and the next platform ahead. Then the wall loop restarts. The game is waiting for user input, and once the player holds down the mouse, a new stick is drawn. In a less favorable scenario, the same phases are following each other, but in the walking phase, if the sticks didn't fall on the next platform, then the hero will only walk till the edge of the stick and then it will fall down. So how do we realize this in code? This game has essentially 3 parts. First we handle user input, especially mouse down and mouse up events. Then there's a main loop that changes different variables defining the state of the game based on the current game phase and time. And finally there's a draw function. The main loop will call this at every cycle, and the draw function ultimately repaints the whole scene based on the state of the game. So let's get a bit more into the details regarding how these work. Handling user input is fairly simple. We are listening to the mouse down event and the mouse up event. Once the player holds the mouse down, we initiate the stretching phase by setting the phase to stretching, resetting the timer that the main event loop uses, and triggering the main event loop. But all these are only happening if the current state of the game is waiting. In any other case, we ignore the mouse down. The mouse up is even simpler. If we are currently stretching a stick, then we stop that and move on to the next phase when the stick falls down. Then let's see the main event loop. This is a request animation frame loop triggered by the mouse down event that keeps on invoking itself till we don't stop it by returning from the function before it reaches the last line. The request animation frame function receives a timestamp as an attribute, and this attribute we can use to calculate the time passed since the last cycle. And based on the time passed, we can calculate how the game should change based on the current phase of the game. If, for instance, we are in stretching phase when the player is holding the mouse down, we need to grow the stick as the time passes. We calculate how much longer it should be based on the time passed and the speed value that defines how much time does it take for the stick to grow 1 pixel. A very similar thing is happening in every other phase as well. In turning phase, we change the rotation of the stick based on the time passed. In walking phase, we change the horizontal position of the hero based on time. In the transitioning phase, we change the offset value of the wall scene, and so on. In most of these phases, we also have a threshold value that ends the phase and triggers the next one. The waiting and stretching phases are the exceptions, because their end is based on user interaction. But the turning phase, for instance, stops when the stick falls flat and its rotation reached 90 degrees. The walking phase ends when the hero reached the end of the next platform or the end of the stick, and so on. If these thresholds are reached, the main game loop sets the game to the next phase, and in the next loop it will act accordingly. Let's see these in more detail. If we are in waiting phase, nothing is happening. We return from the function. This return statement also means that we never reach the end of the function, and there won't be another request of an animation frame. The loop stops. And we need the user input handler to trigger another loop. In the stretching phase, we increase the length of the last stick based on the time passed and wait till the user is releasing the mouse. In the turning phase, we change the rotation of the last stick. We only do it till the stick reaches 90 degrees because that means the stick reached a flat position. Then we set the phase to walking, so the next request animation frame will adjust the hero and not the stick. Here we also increase the score value if the stick fell on the next platform. But we don't trigger failing yet if it didn't, because even if the stick didn't hit the next platform, the hero will still try to walk through it. Then in walking phase, we move the hero forward. The end of this phase depends on the stick reaching the next platform or not. If the stick fell on a platform, then we limit the hero's position to the edge of the platform. Then once it's reached, we go to transitioning phase. If the stick didn't fall on a platform though, we limit the hero till the end of the stick, and then we start the falling phase. In transitioning phase, we move the whole scene. We want the hero to stand at the same position of the screen where it initially stood, but now it's standing on a different platform. So we have to calculate by how much should we shift the whole scene to achieve the same position. Then just set the phase to waiting, and we wait for another mouse event. In the failing scenario, two things are changing: the hero's position and the last stick's rotation. Then once the hero fell out of the screen, we stop the game loop again by returning from the function. So that's the main loop, how the game moves from phase to phase, changing a range of variables. Let's move on to the part of painting the scene to the canvas based on these variables. The draw function takes into consideration the variables which change the main loop and paint the whole canvas. It shifts the whole UI by the offset, puts the hero in position, and paints the platforms and sticks. When we use Canvas, we have a coordinate system with a center at the top left corner of the screen that grows to the right and downwards. But how do we paint things on it? We won't cover everything here, just walk through the framing of the canvas and how to paint a rectangle and the shape. We define the canvas in HTML, then get its context in JavaScript. With the draw function, we repaint the whole screen every time, so first we need to make sure that it's empty. We also want to make sure that the screen has the correct framing. After the hero walks from one platform to another, the whole game should shift to the left. We change the scene offset value to keep track of this shift in the main loop. Now we can use this variable to translate the whole layout. It's important that we do this before we paint anything on the canvas, because the translate command does not actually move anything on the canvas, but shifts the coordinate system. So anything we paint afterwards won't use the original coordinate system. The 0, 0 coordinate won't be on the top left corner anymore, but it will be a bit to the left, and anything we paint will be painted accordingly. The translate commands accumulate, meaning if we call the translate command twice, the second doesn't just override the first one. We will add the shift on top of the first command. That's why we always need to reset the transitioning. So next time we start with a clean slate, and the 0, 0 coordinate will be on the top left corner again. We do this by calling the restore command after we don't want to be in this shifted coordinate system anymore. The restore command resets transitioning to the state the canvas was at the last save command. That's why we often start a painting block by saving the context first and end with restoring it. So that was just the framing, but we haven't painted anything yet. Let's start with a simple one, drawing platforms. The metadata of a platform is stored in a platform array. It contains the position of a platform and its width. We can iterate over this array and fill a rectangle by setting the starting position and the width and the height of the platform. Note that the y-coordinate is upside down. It's growing from top to bottom. What is interesting about Canvas, or at least it was surprising to me, is that once you paint something on the canvas, you can't modify it. It's not like you paint a rectangle, then you change its color. Once something is on the canvas, it stays as it is. Like with a real canvas, once you painted something on it, you can either cover it by painting something over it, or you can try to clear the canvas. But you can't really change existing parts really. That's why we set the color here up front and not afterwards. Then let's see how to paint a stick. This is a bit trickier because we need to shift coordinate systems again. The sticks are stored in an array in a similar fashion as the platforms, but have different attributes. They all have a starting position, a length, and a rotation. Remember the last two we changed in the main game loop, and the first one, the position, should fit the edge of the platform. First we need to use the translate command again to set the center of the coordinate system to the edge of the platform. This is important because in the next step we are going to rotate the stick, and the anchor point of the rotation is the center of the coordinate system. So if we want to rotate the stick from the edge of the platform, we need to move the 0, 0 coordinate to the edge. Then we rotate the stick based on its rotation. When we are in stretching phase, this value will be 0. We are not actually rotating the stick. And once it fell down, it will be 90 degrees. But while turning, it can take any value in between. This rotation again won't rotate anything that's on the scene already, but it will turn the coordinate system that we will use in the next step when we are drawing a line. So by the time we reach the actual drawing part, the starting point of the stick will be at 0, 0 coordinate and the coordinate system will be turned. In this example, we draw a line upwards. Both its beginning and its end has the same x coordinate, only the y coordinate is changing. Yet the line is heading to the right because the whole coordinate system has turned. Now upwards is to the right. It's a bit mind-twisting, but you can get used to it. The actual drawing of the line is also interesting. There's no simple line drawing command, so we have to draw a path. We get a path by connecting multiple points. We can connect them with arcs, curves, and straight lines. In this case, we have a very simple one. We just begin a path, move to a coordinate, then draw a straight line to the next coordinate. Then we finish it with the stroke command. We can also finish a path with the fill command, but that only makes sense with shapes. The hero part I'm not covering in this video, but you can find the whole thing on codepen. There you can also see how to draw a simple triangle shape, how to draw rounded rectangles by combining arcs and straight lines, and how to add a background. So that's what I wanted to cover. Thank you for watching. If you want to dig deeper into the code, you can find a whole game with its source code and many comments in the description below. So hope you enjoyed this video. If you like it, please subscribe. I'm planning to do some of these in a similar fashion in the future. So hope to see you at another one.